All right, let's talk about if-then statements. And an if-then statement is really a statement that's trying to connect things. Right, so it's really about a connection. And so you might say something like, "Hey man, you should study. You probably do better on the test." And so if we put that into an if-then statement, it might look something like, if you study, then you'll do better in school. Right, it's drawing a connection between studying, this event, the study event, and then better in school. How about if you exercise, then you will gain muscle. Okay, so it's talking about connecting exercising to gaining muscles, right? And there's an order here. It's studying, then it says better in school, exercise, gain muscle. And there's mathematical things, right? So you can say if the sum of number's digits are divisible by 3, then the number is divisible by 3. Right, that's kind of like a divisibility rule. So you can look at, it doesn't matter, you can look at 75, right? Or you can, right? And so you're like, I don't know, does 3 go into 75 or not? Well, if you take 7 plus 5, you get 12. 12 is divisible by 3. So if the sum of a number's digits are divisible by 3, meaning 12, then the number is actually divisible by 3. And so yes, 75 is divisible by 3, meaning 75, you can divide 3 into 75. In this case, you get 25. So there's math things that are if-then statements. And what we want to do is we're going to call these, right? So this is like, this statement leads to this one. There's a connection between those things. And so the original statement, we usually use letters. P implies Q. Study implies or leads to or is connected then to or causes then better in school. Exercise, muscle. Digits are divisible by 3, numbers divisible by 3. Okay, so we have the statement, and then algebraically, symbolically, we also have other things. We have what they call the converse. The converse statement is actually Q implies P. So you switch those. You have the inverse, which is not P implies not Q. And again, we're going to go over this in a second. And then you actually have something called the contrapositive, which is not Q implies not P. Okay, so this little symbol here means not. Okay, this is P implies Q, and so let's just look at maybe this. So let's say the original statement is, if it is sunny, then I will golf. Okay? The converse is, if I am golfing, then it is sunny. Okay, so I switched. Here it was sun leads to golf, and then it was golf leads to it being sunny. And there's not necessarily a causation there, but it's just saying there's a connection there. The inverse is saying if it is not sunny, then I will not golf. And the contrapositive is if I am not golfing, then it is not sunny. Okay, so we have sun to golf, golf to sun, not sunny, right? Not P, not golf, and then not golfing, not sunny. And what I really want you to think about is the equivalence of those things. And it will turn out that these two statements logically are actually saying the same thing, the converse and the inverse, and the statement, the original statement, and the contrapositive are logically equivalent. Logically equivalent, meaning they actually mean the exact same thing. Okay, so let's assume right now that the statement is true. If it is sunny, meaning if it's sunny out, then I'm for sure golfing. And I claim that this is the same thing, because this says if I am not golfing, then it must not be sunny. Same thing. If this is a true statement, sun will always lead to golf. Then if you know I'm not golfing, then you also know it must not be sunny, because if it was sunny, I'd be golfing. Okay? So the statement and the contrapositive are actually the same. The converse and inverse are the same. So let's assume this is true. If you knew I was golfing, then you knew it was sunny. But if it was not sunny, then I won't be golfing, because if I was golfing, it would be sunny. Again, hopefully you can see that these two statements are logically equivalent, and the first and the fourth are logically equivalent. We in geometry will focus on these for sure. These guys. Okay? So, for instance, and sometimes they're both true, right? I'm going to give you the Pythagorean theorem. The Pythagorean theorem, the shorthand of that is if you have a right triangle, which means one of the angles is 90 degrees, then the Pythagorean theorem is true. That's the Pythagorean theorem. It says, hey, we've decided that if you have a right triangle, that we know the relationship then, as long as you have a right triangle between the legs and the hypotenuse, is this. If this, then this, right? This is P and this is Q. Well, the converse of the Pythagorean theorem we actually will use, right? Let's switch these. It will be that if you can show me that this is true, then what do you know? Then you know you have a right triangle, meaning you have a 90-degree angle, okay? So we actually use the converse a decent amount in geometry. We will not discuss the inverse and the contrapositive very often, but they are logically equivalent to those. Again, the original statement is right triangle, Pythagorean theorem is true, but the converse is true. If ab squared plus b squared equals c squared for a triangle, then you know it's 90 degrees. Okay, let's do maybe one more thing to kind of discuss logical equivalence. Let's say I say dogs. All dogs have, or if you're a dog, then you have 4 legs, right? The converse would be if you have 4 legs, then you're a dog. The inverse would be not dog, not 4 legs. And then the contrapositive would be not 4 legs, not dog. And again, in this scenario, I just want to prove to you again that the first and the fourth are logically equivalent, okay? In this particular case, this is true, okay? Of course, if you're a dog, then you have 4 legs. And then this one is also true. Remember, they are the same thing. If you don't have 4 legs, you can't be a dog. because if you're a dog, you have 4 legs. Same thing. This is false. If you have 4 legs, then you're a dog? No. Lots of animals have 4 legs. Just having 4 legs does not mean you're a dog. And then this is also the same thing. If you're not a dog, that means you don't have 4 legs. Well, no, because you can be a cat and then you still have 4 legs. So this is false. Again, I'm not saying that every single time the statement and the contrapositive are true and both of these are false, but I am saying that if this guy is true, then this guy is true. If this guy is false, then this guy will also be false because they are logically equivalent. Okay? So in the worksheet, you'll turn statements into if-then statements. If I give you a statement, you should be able to write the converse and the inverse and the contrapositive. This is kind of the geometric version of kind of looking at a statement and a converse. And again, both the statement and the converse of the Pythagorean theorem is true. But again, you don't have to every if-then statement. You can write if-then statements that are false. Clearly I have, if you have 4 legs, then you're a dog. That's a false one. Okay, I think that will get you started on the notation with P's and Q's and nots and implications here and writing if-then statements.